Well, let's look at a couple more questions here and really get involved with our calculator and understanding how to do this stuff and just make it, second nature to us all. Look at this particular question. Notice that you've got your parabolic function on this side, but now it equals to something. So in fact, you're not finding root anymore, you're finding a solution. That's kind of interesting, isn't it? Now, there's two ways of solving this. You can rearrange the equation to make that equal to 0. So basically, you're going to make this go x squared plus 6x. You're going to move the 9 over to this side. You get plus 9 equals to 0. There it is. You could throw that into your calculator and find the solutions. Let's do that first, okay? So I've got my equation in here, and I'm just going to hit graph, and let's see what happens. Boom. Look at that. There's my solution right here. And it looks like it's probably -3. Well, let's prove that. Let's go out and find, in fact, if that's -3 or not. Second calc, let's find our 0. Left bound, here we go. Whee, all the way down here to the left side. And I think you're getting pretty good at this by now. Enter. Go over to the right side and enter, and of course guess, and sure enough, in fact, it's at -2.9999999. Yeah, -3. Okay, so our solution here is -3. That's quite interesting to see. But what happens if I didn't move this over? What would happen if I left this as x squared plus 6x equals to -9? What can I do now? Well, simply, you can just go out and take this guy, make that y1, take this guy and make that y2. Why? Why can you do this? You're going to make these separate equations. Watch what happens when you do that on your calculator. So I've got it set up in the calculator here under y1. You can see there's the x squared plus 6x. There's the y2 equaling to -9. Now I'm just going to graph this. I want you to see something. Look at that. You have two separate graphs. Well, of course you're going to have two separate graphs. This first graph is going to be the x squared plus 6x. This is going to be the -9. How can you tell? Look, 1, 2, 3, 4, 5, 6, 7, 8. There's -9. It goes through the -9 all the way through. So what are you doing now? How can you solve this thing? Well, in fact, since you've got two lines, go into second and calc, and look what you're looking for. You're looking for no longer the 0, because it equals to -9. You're not looking for the 0 anymore. This is a line or a curve. This is a line. Well, guess what? You're looking for the intersection of those two lines. And I want you to see what that intersection is. Let me clear this out of here so you can actually see it. It's going to freak you out. So intersect, hit 5, and it asks you, what is the first curve? So I'm going to mouse close to the answer, which is down here. I'm going to hit enter, and look, it brings up the second curve. How do you know you're on the second curve? Look up here. It says y2 is -9. There's your second curve. Hit enter. And then it's going to say guess. And look at this. Look at your answer right away. It's at -3. Do you remember when we did it the other way? What it was on? It was at x equals to -3. Again, you don't care what the y is. And that's one of the reasons why this works. Two different methods. You can figure this thing out by originally putting the original graph by making it equal to 0 and finding the solution is -3, or putting one line down, putting the other line down, y1, y2, and finding out that, in fact, it is x equals to -3. No matter which way you do this, it ends up with the same solution. I think that's kind of cool.